All right, today we start solving log equations. So remember to pause me if I'm going too fast or you need to go back, rewind, look at something. We're going to go to Desmos.com today, and once you get to Desmos, just click Graphing Calculator until you get to here. I minimized the screen down small, but we'll use that not as a graphing calculator, just as a regular calculator. Okay, here we go. 8.5, solving log equations. If there's a log on one side, here's what you do. So the whole front of this notes is solving with a log on one side. You switch forms, first, last, middle. So you have first, last, middle. Now in the next part, you never know what's going to happen. You just have to use all your solving skills to get to the answer. So here's what I know. 36 is actually 6 squared. So I rewrite it. You just hedge the 36 to find that out. So you would have divide by 6 and get 6, divide by 6 and get 1. Normally, with hedging, you have to divide by the smallest possible number, but here I didn't do that because I noticed that 6 would work really perfectly. All right, we're almost done already. Write that 6, bring it down, and now we figure out the exponent. What is 2 times 3 over 2? So you want to put that in your calculator. We'll go to Desmos right now, unless you have your own calculator that you like better. 2 times 3 over 2. 2 times 3 over 2. So if you didn't already, you want to click show the keypad down here so it pops up. 2 times 3 over 2. So 2 times 3 over 2. And it should say equals what the answer is here in the corner. And if it doesn't, just hit enter and then it'll pop up. So we found the answer is 3. So back to here. If we multiply the exponents, we get 3. So now we just need to find out what 6 cubed is. So back to the calculator. 6 to the power, where are you? It's a to the power b. This is our caret button. 6 to the power 3 is 216. 216 and done. Now these ones have mandatory checking. All you have to check is that the argument is positive. And remember, the argument is this part right after the base. Here's the argument. Here's the argument, the x. For this problem, the argument is 49. What's the argument for this problem? 3. What's the argument for this one? 81. It's the thing right after the base number always. So you have to double check. Is the argument positive? If I put 216 right here, I've got 216. It's positive. So I checked that it's a positive argument. I'll write the words out for this first one. Positive argument. Next one. We start by switching to exponential form, first, last, middle. Then you hedge the 9 to break it up, and we find that it is 3 squared. Now we just bring down that big 3 and find the exponent. What's 2 times 3 over 2? I think that's the same thing we just did. 2 times 3 over 2 is 3. And 3 to the third power is 27. And if I plug that in, I've got 27 for my argument, and that's positive. So check mark, it works out. It has a positive argument. Next one. We switch forms. First, last, middle. Then we hedge. 16, if you want to divide by 4s, go for it. I'll divide by 2s to get 8. 2, 4, 2, 2, 2, 1. So it's 2 to the 4th. $16 turns into 2 to the 4th. So now bring down that 2 and let's multiply the exponents. So we're multiplying 4 times 5 over 2. So back to that Desmos calculator. I'm going to hit enter to go to the next box. 4 times 5 over 2. 4 times 5 over 2 is 10. Oh boy, I'm realizing this is going to be a big number. 2 to the 10th power. Let's find it. 2 to the power 10. 1024. So let's check. If I plug in 1024, I have a positive argument. Check mark. So that works out. Next one, same thing. First, last, middle, hedge the 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So I get 2 to the 3rd to the 4/3. Now you just bring down that base 2 and multiply the exponents. I bet you can already tell that the 3's cancel and we just get 4, but I'll show putting it in the calculator anyway. 3 times 4/3. 3 times 4/3. Enter. So it's 4. Almost finished, but not quite. What's 2 to the 4th power? Not 8. It's 16. So just double check. Is our argument positive? 16 is a positive number, so yes. Check mark. It has a positive argument. Done. Okay, now we have a change of pace from this row of problems to the next row of problems. Look at it and see if you can tell the difference. The difference is where the x is. For this row we just did, the x was always the argument. These problems, the x is actually the answer on the other side, but it'll still be pretty easy to do. Here goes. You do first, last, middle. Almost done already. Now it's like that solving exponential equations homework where you hedge. When in doubt, hedge. We are hedging all the time in Algebra 2. I hedge and find that I get 7 squared. Now I can cancel the 7's and get 2. Double check, is the argument positive? The argument is 49 and the answer 2 doesn't even affect that. So it checks out. We have a positive argument. You hardly even need to check this one. Next one. You do first number, last number, middle number. You know the drill. Hedge the 27 to get 3 cubed. Don't forget the x. Other side, be careful. Right here, you should probably stop and write the invisible 1 exponent so you don't forget it. Now we can cancel out the 3's to get 3x equals 1. Divide to get rid of the 3, and we're done. Just check. The argument is this 3, which is positive. So check mark. It has a positive argument. This front page is way more work than the back side of the page. These ones are the hardest problems, actually. Here we go. First, last, middle. This is one of those ones where you have to hedge both sides. So hedge 27 and get divide 3, 9, divide 3, 3, divide 3, 1. Hedge the 81. Divide 3, 27. Hey, we just hedged that. Divide 3, 9, divide 3, 3, divide 3, 1. I've just found that 27 is 3 cubed and 81 is 3 to the 4th. Go ahead and cancel the base. So we have 3x equals 4. Now divide by 3. And we get x equals 4/3. And yes, we have a positive argument. So we are done. So once again, the top row and the second row had slightly different ways to solve, but it's all stuff we know and have been practicing. All right, let's do some easy ones. Back of the page. The log property of equality says if you have the same log on both sides, you can cancel it. So then you just have what's left as the argument, x equals 26. So these are great. They just cancel. They look way more complicated and then they turn out to be the easy ones. Cancel the logs. Include the base is part of the log, so don't write those 10s anymore. X plus 2 equals 6. How do you solve? Subtract. We have x equals 4. So you are done, except you have to check for the argument. Here's the argument, x plus 2. If I plug in that 4, I get 4 plus 2 is 6, which is positive. The other argument is also 6, which is also positive. So I can keep this, check mark. It is a positive argument. Next one. The logs are the same. They're both log 2. Cancel. Divide by 2. Now check. You have to check. If I plug in 4, 2 times 4 is 8, which is a positive argument. Same on the other side. I can keep this as my answer because it has a positive argument. Positive argument. Next, we cancel. X minus 15 equals 2. Add the 15. Now we check. If I plug 17 back in, 17 minus 15 is 2. That's positive, so it checks out. We have a positive argument. Last one, cancel the logs. Whoops, almost crossed out the wrong thing. X minus 4 equals negative 3. Add the 4. X equals 1. Now we check. If you plug in 1, 1 minus 4 is negative 3. Nope, this is no good. It's a negative argument. We can't have that. So that 1 that we just got is an extraneous solution. So write extraneous and make sure you spell it correctly. Extraneous solution, which means there is no solution. So write a circle with a slash. That's the symbol for that. That's why we have to check. We did all the work correctly, but you can't have a negative number. If you were paying attention and saw this right here at the beginning, you wouldn't have had to check at all. You wouldn't even have to solve. You already know there's no solution. That's it.